Hello again, welcome back. Right, what I want to look at today is Norton's theorems. Now, remember that on my channel I have done something on Thevenins, and what I wanted to do was to show that Thevenins and Nortons were working or have carried out work in a similar area, and that there is a connection directly or indirectly. Okay. Sorry. Now again, I'm not going to read this through to you, but what I've done is to do an example as to what Norton has done in regards to a given circuit. Now you can read this for yourselves, so I'm not going to read this through to you, but what I've tried to do here is to give you an outline or an overview as to the view that you cannot have a current without a source of voltage, no matter how small that voltage may be. And here I'm simply looking at now, we are going to calculate how to calculate the current using Norton's theorem. Now I will be using a diagram you may have seen before if you've done the work on Thevenins before, okay? Now again, make sure you write out all the work and you draw the diagrams. Do not leave anything out because everything is tied into it. Okay? Now, what I'm looking at here is just to indicate that you can only have current flowing in one particular circuit, and I've simply recommended here that you use your finger starting from the point of the battery and follow the circuit round. Okay. And here we have the diagram which shows you taking into account, assuming that the value of all the resistors has been calculated, and that is the only resistor you will have in circuit. Okay. Now this excludes the load resistor. And again here you can read this for yourselves. Don't need me to undermine or take that into account. Okay. Now look at what I've done in regards to the formula for calculating the total resistance. I've said RT equals R2. Now remember that I've put a reminder here of BODMAS because remember you must follow the rule of BODMAS in any mathematical equations. Okay. Again here I'm leaving that for you to read for yourselves and put in the information. Now I've now moved down, and what happens now, all I'm doing now is giving you a guided note as to what I will be doing next. So read the notes, write them out. Do not assume that you know it offhand. It doesn't work that way. There are no shortcuts. Okay. Let us look at an example. Okay. Example P1. Okay. And all I'm going to do here is to take you through it. You'll see that you have the original diagram. just to make sure it is readable. Okay. Then we're going to look at this solution. Now here we need to solve for the parallel circuit first before we do anything else. And again, I'm just going to follow that down. Again, write this out. Do not take it from the screen or just look at it on the screen and think you will know how to do it. You must write it out. Okay, and here we have total resistance of 30.91 kiloohms. Okay. Now we now need to find the voltage, open circuit, across A and B. And again, I've shown you how to do that. Write it out. Okay. And you should be able to follow this for yourselves now without me talking over it. Okay. You can see that we have total current there is 0.315 milliamp in the circuit. Okay. Now here I'm going to use a formula from J.B. Prattley's study notes, which I used many moons ago. Okay. And this is the formula I've decided to use to assist me in solving and calculating the current and the voltage at the point of the load. Okay. Now again, you can read this for yourself and you can write this out for yourselves. And here I've given you the final product as what the circuit would look like, basically. Okay. So you can almost say whatever voltage appears across the final value of the resistor should also appear across the load. Okay, and I think that's it at this point. Thank you again. Have a good day. Let's go back to make sure that we have everything in. Okay, and you see that the current here that's actually in the load is 0.238 milliamps. Please note that's 0.238 times 10 to the minus 3. So you must use standard form. Okay, begin to apply that for yourselves. If you don't know what standard form is, you need to look it up. It's in your electrical principles book. Thank you. Okay, have a good day. Thank you. Bye bye.